To get started on a feasible set problem, the first thing we want to do is graph these lines. I'm going to call this line line number 1. So over here, when I talk about line number 1, I'm going to copy down what the problem looks like, and I'm really only interested in the lines. I'm going to put an equal sign there. In order to graph this, I'm going to graph it by using intercepts. So I'm going to make the x value equal to 0. So I'm going to have 5 times 0 plus 2y equals 14, which gives me 2y equals 14, and y equals 7. So I've got the ordered pair now, 0, 7. I'll go ahead and make y equal to 0 and get 5x plus 2 times 0 equals 14. And I end up with x equals 14/5, which is approximately equal to 2 4/5. So my ordered pair now is 2 4/5, comma 0. So that'll make graphing this one not so bad. I'll come over here, I'll count up 7. 1, 2, 3, 4, 5, 6, 7. I'm going to go ahead and label that as one of my points. Down here, 2 4/5 will be about right here. So then I can go ahead and connect these that way. Now I also want to go ahead and make sure that I label this as line number 1. Okay, I'll go ahead and do the same thing with line number 2. I've got line number 2 as x plus 3y is, I'm going to make it equal to 8, so I'm just concerned about the line here. Making x equal to 0, I've got 0 plus 3y equals 8, and y equals 8/3. Same thing as 2 2/3. Gives me an ordered pair of 0 and 2 2/3. I'll come down a little bit and go ahead and find out when y equals 0. I've got x plus 3 times y equals 8. X equals 8. So I've got the ordered pair 8, comma 0. So now I'm going to go ahead and plot those two. 0 and 2/3 is about right here. I'm going to go ahead and label that since it's not exact. And down here I've got 8, 3, 4, 5, 6, 7, 8. We'll label that. That's 8, 0. And then I'll just go ahead and connect those two this way. And I'm going to be sure to label this as line number 2. Now, the line x is greater than 0 and y is greater than 0, those take care of our axes. So I'm going to go ahead and shade now. When it comes to shading these lines, I want to make sure that I look at the original symbol, which in this case was a greater than. So when it comes down here to line number 1, I want to shade things that are, my answers are numbers that are going to be greater than y equals 14. I think the best thing to do for these is go ahead and just choose a test point. So when I choose a test point, I'm going to choose the point 0, 0. So I'm going to plug in a 0 and a 0. 5 times 0 plus 2 times 0 is greater than or equal to 14. 0 is greater than or equal to 14, which is false, which means the point 0, 0, which is down here, gives me a false answer. So that means that all the points that are on that side of the line are going to be false. So I'm going to go ahead and cross off all of the values that are in that same area. Remember, for these feasible set problems, we want to be left with the clean area as the part that works. So then if I go ahead and do the same thing down here and plug in 0, 0, I've got 0 plus 3 times 0 is greater than or equal to 8. 0 is greater than or equal to 8 is false, which means that all the points on this side of the line are going to be false. I'm going to cross them all off. Remember that when x is greater than 0, we're talking about areas that are above, to the right of the y-axis. Y is greater than 0 are points that are above the horizontal line. So the areas that I'm looking at, I'm going to cross off parts that are below, and I'm going to cross off parts to the left, which leaves me with a feasible set in here. My only last issue to figure out is I've got to define my feasible set by giving the vertices. There's point A, here is point B, and then here is point C. Now when I think about those, I'm going to go ahead and label them. I've got point A, I've got point B, and I've got point C. Point A, because I did a good job of graphing, I know already is the point 0.07. Point C, because I did a good job graphing and labeling, I know is the ordered pair 8, 0. So now all I'm left really is to figure out what point B is, and point B is the intersection of line 1 and line 2. So with line 1 being 5x plus 2y equals 14, and line 2 as x plus 3y equals 8. I can go ahead and use any method that I want to go ahead and solve this. I can use elimination or I can use substitution. I think probably the easiest thing to do here would be to do some elimination. I'm going to multiply both sides by -5. So what I end up with is 5x plus 2y equals 14. I've got negative 5x minus 15y is equal to negative 40. And I can go ahead and find my ordered pair this way. I end up with negative 13y is equal to negative 26. So y must equal positive 2. And at this point, I'll just go ahead and plug that back in to find out what x is. I'm going to plug it back in here. So x plus 3 times 2 is equal to 8. And x equals 2. What that tells us is that point B is the ordered pair 2, 2. And we just want to make sure, looking at the picture here, that B is at about the point 2, 2, which makes sense. Our graph isn't perfect, but we can see that it is close. So now our feasible set is defined. We know where the area is, which is in here, and we know where the vertices are.